things first. Today what we're doing is we're going to do a little bit more review of chapters 10 and 11, and then we're going to cover chapters 1 through 6, kind of start touching on all of those. And then I have the magic trick to show you folks. The one thing I did last class, so I won't do that again. Today you have due My Open Math 11.2, and then next Tuesday you have 11.3 due. The final is next Thursday, a week from today. So don't forget, exam 4 is rolled into the final. So 35% of that final is going to be exam 4 material. And the rest, about 20% of that exam will be exam 1 material, 20% exam 2 material, and about 25% exam 3 material, approximately. Your final is going to be, it's technically scheduled for 5:30, but you all want to take it at 4. Yeah. So we'll do that. And then, again, a reminder, the problems are grouped by exam. So I'll put all the exam 1 material together, and then the exam 2 material together, then the exam 3 material together, and exam 4 material together. Or the opposite, depending on which version of the test you get. And remember, within the exam, all the problems are mixed up. All right. Review session for this class is going to be 4 to 5. Next, 4 to 5:15 next Tuesday. So it's here, but if you folks want to see the cat, is that right? So you're coming Monday? Is that why you're coming Monday? Yeah. Yeah, Monday it will be.
That's also the longer review, right?
It is longer, yeah. So Monday it's from 5 to 6:45. I changed the time a little bit.
Okay.
Yeah, it's 5 to 6:45 on Monday, and my cat will be there for that one. So you are free to come to that one if you like. Quick reminder about claims, because remember, the wording that you get, that kind of determines whether your H0 or H1 is your claim. So the H0 type claims for chapter 10 and 11 are things like equal, independent, no relation, the same, as expected, because that's also equals, right? No difference, that's also equals. And the no's, no correlation, no line. H1 claims are the opposites of that. Not equal, dependent. So remember, independent is when the proportions are equal. So dependent is when they're not equal. So that would be H1. Related, not the same, not as expected. Different, correlated, or it is a line. So these are all the flips, the opposites of H0. Generically, these are the ones that I would like to use on the exam for these. No correlation or no line, or there is a correlation. Proportions. And here, let me give you what you'll write to go along with that. You would write rho is equal to 0, or rho is not equal to 0. Oh, sorry, R, rho. For the chi-squareds, those are all about proportions. So the proportions are as expected, or the proportions are, oh, this is messed up, or the proportions are not as expected. So again, this is the O sub I equals E sub I, and the O sub I is not equal to E sub I. And then the ANOVA is just when all the means are the same. So mu1 equals mu2 equals mu3. Or the means are not the same. So at least one differs. Now, for the exam, the homework may not match this, but for the exam, your chapter 10, H1 is going to be the claim, that they are correlated, that it is a line. And then for chapter 11, the chi-squareds and the ANOVA, the claim is going to be H0, that that they fit some expected values, or the means are the same. The final is going to cover all the chapters, chapters 1 through 11. You get 1 page of notes, both sides. You can use your half-page notes, one-sided, from the previous exams if you like, or any combination thereof. As long as you have that total amount of notes. 1 page, both sides. You can use any tables you want, your magic formula sheet. Bring your binder so you can get extra credit. I only need chapters 10 and 11 in there, the notes and quizzes for chapters 10 and 11 there in the back of the room. Underneath that table back there if you need them. Make sure you get them if you don't have, if you're missing any. And then don't forget your TI calculator. I will bring some along in case people don't have one, as always. This is the study guide for the final. These are the problems you need to know from the previous study guides. So that basically is the study guide. Oh, sorry, this should be 5 o'clock. 5 to 6:45. There we go. But I think you folks all have that already. And tutorial center, this is no longer useful because this is the last one, and really this is going on right now, so she's only going to be there for another 20 minutes, so not so useful anymore. All right, so the F statistic for ANOVA, it's quite complicated, but the bottom line is finding these two numbers are complicated. But the F statistic is basically the ratio between the variance between your groups over the variance within the groups. So in other words, if the groups have the same mean, then their variances, here's the first group, second group, third group, then the variance within the group will be the same as the variance between the groups. And this ratio will be 1 or close to 1. But the groups have different means, then their variance within their group will be a lot smaller than the variance between the groups. This between group variance will be larger than the within group variance, so this is going to be, the F statistic is going to be a lot larger than 1, or fairly a bit larger than 1. So that's the ratio, and I do expect you to understand that concept. That's the variance between the groups divided by the variance within the group. So on the final, I'll give you those two numbers. I might call it group instead of sample. And I might mix the words around, so it might be between group variance or between sample variance or variance between groups, that sort of thing. But one will be between and one will be within. The between is between them, the within is just within that group. And you need to find those two and divide them to get your F statistic. And I'm going to give you other things to confuse you along the way, right? I'll give you X bar and S and N's and other stuff, right? But these are the pieces that you need. Okay. We spent a fair amount of time last class on this part. I think we all can agree that chapters 10 and 11 are two of the easiest chapters we've hit this semester. The difficulty is knowing which kind of problem you have, because if you know you have an ANOVA, 11.3, boom, easy to do it. But if you take a chi-squared matrix and you do ANOVA to it, then you've just lost like 15 points on the exam, right? So it's really important to make sure you understand which problem you have and tell them apart. So first we're going to take a look at the variables. So variables are, what do you know about each of the people in your sample? And so think about what question was asked each person in the sample, and not really the question, but the answers. Are the answers numbers, numerical, or are the answers categories? Like blue, red, green, those are categories. 14, 12, 6, those obviously are numerical. So what you know about them are numbers, like for example, the number of cars a dealership has and their revenue for the year. Those are numbers. That's going to be two numerical variables. That's linear regression. Correlation, linear regression. So it's going to be linear regression, chapter 10. If what you know about them is our categories. So again, they're going to have words like possibly frequencies will be in there. Categories will be in there. Proportions might be in there. So what you know about them is, a color, or what cuisine of restaurant do they like? Like Mexican food, Japanese food, Italian food. Then that's categorical. If you know one variable about each person, that's going to be that goodness of fit test. So GOF is when you know one variable. That's 11.1. And if we know about them are two variables, then that's going to be the matrix. That's the chi-squared matrix. And the last possibility is if what you know about them is what you know about them is a number, but then you also know what group they're in. So you actually know what group they're in and also a number, so you kind of know one is a category, but the second thing is a number. And it will always say mean on there. Always. They're talking about means, or at least averages. So that's the ANOVA. 11.3. This one's 11.2. Another way to look at it, which some students in my previous classes really thought was useful, is think about whether you know one variable about each person or two variables. If it's two variables and they're numbers, then that's a linear regression. If they're two variables and they're categories, again, they might say things like frequency or proportion, have percentages in there. That's going to be the chi-squared matrix. If it's just one variable and it's a category, that's the chi-squared list, the goodness of fit test. And if it's a number, then that's ANOVA. But again, you'll know what group they're in as well. So let's just take a minute on your own for 15 seconds, try to figure out what kind of problem each of these is visually. So without talking, just for 15 seconds. All right, let's take a look. So let's take a look at this far one over here. So visually, I have labels here. I do not have labels there. If you only have labels on the side or the top, it cannot be a matrix. The chi-squared matrix has to have labels across the top and along the side both. If it's only one or the other, then those are lists. So this is a list. These are lists. I have two lists. So it cannot be ANOVA because ANOVA is three or more lists. So this one has to be what? Linear regression, chapter 10. Everybody good?
Yeah.
All right. Next, let's take a look at this guy here. I have labels there, I have labels there. But now let's make sure that there actually are labels. So football, baseball, hockey, are those really labels? Yes. Those are different categories, different answers to a question. How about male, female? Are those labels?
Yes.
Yes. Right? So those are definitely also. So this is the chi-squared matrix. And again, it's outdated because it only doesn't have non-binary, but we're fine with that for now. Chi-squared matrix. 11.2. And then the next one down below, we've got groups here and groups there. So first I'm thinking chi-squared matrix, but now we got to check and see. Are these all categories of the same variable? Mm-hmm. Accidental, homicides, suicides, yes.
Yes.
How about this one? Observed expecteds?
No.
No, those are not. So really, observed and expecteds, those are two separate things. You have your observed values and your expected values. So if I look at my observed values, it's just these three values. So it's not even a list because it's like accidental is a list of one. That's not a list. It's just three different categories with a value in them. And then you have another one for your expecteds. For the chi-squared matrix, that matrix is my observed values. If I were doing expecteds, I'd have a separate matrix of expected values. My expected would be a whole other matrix. And remember, we do calculate the first and last one of that matrix, right? And then we compare them all. So this is really what the observed values are. And then because it's so easy, it's just kind of right there and so small, we just put the expecteds right below it so that they're all kind of there and easy to find. So this here is the the GOF test, GOF test, 11.1. And then this last one down here, I have categories there. I do not have categories there. So again, this cannot be a matrix because I don't have categories on both the sides and the top. Instead, I have three lists. Three or more lists is what?
ANOVA.
ANOVA. Yep. ANOVA 11.3. Okay, good. So we spent some time. Okay, so let's take a look at one more. So what kind of problem is this? Check in with your neighbors.
Observed frequencies.
Yeah, there is no table at all, so it can't be a matrix. It can't be ANOVA. It can't be the linear regression. The only thing it can be is GOF because it has this list of things there.
It also says observed frequencies.
Yeah, it has observed frequencies, so it has to be a chi-squared. So since it's not a matrix, it must be the chi-squared. So this is the GOF test. So please take a few moments and find, just do the test real quickly. I'll give you folks, actually just do H naught and step 3. Let's just do that. We'll shorten it up. Okay, so our H naught, what's our H naught for this one?
O sub I equals E sub I.
Yep, O sub I equals E sub I. Everybody all good with that part?
Yeah.
And then we need to do, so I'm going to make my little list here. I've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And I've got observed values and expected values. Have people gotten this far yet with this? Fill in your observed values and then take a thought about your expected values. Remember, observed values, you're always given observed values. Expected values, you always have to calculate. You always have to calculate expected values. Observed are always given to you. It's what they observed in the sample. Okay, so you all have these numbers in here, right? 114 for Monday. Tuesday was 152. 160, 164, 179, 196, and 130. Okay, good. Now, my expected values, well, sometimes I get a percentage, like they say this percent on Monday, this percent on Tuesday, this percent on Wednesday. They didn't do that. Instead, what do they say? Same frequencies. So frequencies should be the same from day to day. If they're all the same, what do I do? Do I take 100% and divide by each one? So that'd be 100 divided by 7? No, because I mean I can't compare 114 to something less than 100. That doesn't make sense at all. I mean, you know, to like some fraction. What do you do?
Don't you add all those up?
Yep.
And divide it by 7? Or?
Exactly. We find our n first. Add them all up. What did you get when you added them all up?
1,095.
1,095. That's our n. N is 1,095. So their expected value is going to be, what do you do, Jason?
Divide by 7.
Yeah, divide by 7 because I have 7 of them. Divide by 7 categories. And then what did you get for that?
156.43.
Yeah. So give me at least one decimal place. At least one. Right, I have 1,095 people. I'm going to split them equally amongst all the categories. So I divide by the number of categories. Okay, so then what do you do from there? Sort it out. Use your lists. What did we say this was? What kind of command what do? Yep, it's a GOF test. Okay, so here's just a fit test of L1, comma L2, and then your degrees of freedom is
6.
Yep, it's the number of categories
-1.
-1, so that's 6. And you got a chi-squared of what?
29.81 or 82.
Yeah.
29.8 and a p-value of
4.25 e negative 5.
okay 4.25. 4.25. Right, so anytime your p-value is larger than 1, that's 425%. So you should say, oh my gosh, there better be an E negative at the end of that. And there is. It's E negative 5, which means you put down 5 zeros. 1, 2, 3, 4, 5. And then the number, 425. Then decimal place goes after the first 0. That's the easy way of doing it. This many zeros, then that number, decimal place goes after the first 0. All right, good, good. Moving right along. So, like I said, we spent a lot of time last class talking about how to tell which kind of problem you have. If you are still not so sure, you have that down. I did a whole files review type of problem. All problems from chapters 7, 8, 9, 10, and 11, all mixed in there. So you get some practice with it. It's in Canvas under Study Guides for Module 4. So let me see if I can pull it up. If you go to Modules, Module 4, there's the Exam 4 and Final Study Guide. And it is this one right here. The type of review type of problem from chapters 7 through 11. And then there's the solutions to it right below that. So those are in there. If you want to practice more. Because like I said, if you do the wrong type of problem, then that could be a lot of points for you losing. And then I do want to again mention all the common mistakes from chapter 3, or exam 3. The most common one was people not realizing that it's either a proportion or a mean. It cannot be both at the same time. It's one or the other. They're two separate things. So if it's a mean, it'll say mean or average or standard deviation, and standard deviation, right? Or give you those things. So if it's a mean problem, then you do not find a proportion, ever. There is no proportions, no p's at all. You have mu's and you have s's and x bars. So a lot of times people would they'd have a mean and then they'd take x bar and divide by n and get some crazy number. So you cannot mix and match those. Means have their own set of formulas, proportions have their own set of formulas. They do not mix one from the other. They're completely separate things. Proportions, remember if you do have a proportion, you're always given n, and you're either given x, the number of people who said yes, or p hat, p, the percentage. How do you know it's p? Has a percent symbol on the end of it. Right? The x will always be a whole number of people. And you can get back and forth between them. You're using p equals x over n, and on the flip side, x equals n times p. Other major mistakes were people not giving all 5 steps. In step 4, you have to say reject or fail to reject H naught. That's key. That's that whole point of this. It's called a hypothesis test because you're rejecting or not rejecting the null hypothesis. So you have to make sure you include that. Some people lost a lot of points with that one. And then the final thing is confidence intervals. What are the 3 steps of a confidence interval? Take a minute with your neighbors. Try to figure out what they are again. What are they? What are the 3 steps of a confidence interval?
Confidence and the confidence interval itself.
Okay, what are they, folks?
The confidence interval.
You have the confidence interval itself, which is going to be the lower limit, comma, the upper limit in parentheses.
And then the margin of error.
Margin of error, oops. The margin of error, which is going to be E, right? So that's if I have, and then what's the last thing?
Point estimate.
Yep, the best point estimate. Best PE, you can call it that, or PTS if you want. That's going to be X bar or P hat, depending upon what you've got. That's the number in the middle. So my X bar is the number in the middle. And then from there, to find my confidence interval, I take that X bar, I subtract E to get to my lower limit. And I add E to get to my upper limit. So then I have my upper limit and my lower limit. Upper limit. All right, so those are kind of all the pieces. If I have the upper or lower limit from my calculator function, then I can find the rest of them. X bar is going to be the number in the middle of it. So if I average these two But then this will also give me, it also gives me my number in the middle, my best point estimate below this on the calculator. It'll give you your x bar or your p hat, depending upon what you have. And then to find the error, it's the distance from between these two. So from x bar to your lower limit, or from x bar to your upper limit. So you can just take x bar, subtract your lower limit, and you'll get your margin of error. Right, so those are kind of the easiest ways of finding those. All right, so next in your handout, go ahead and do problem number 20. It's on, I don't know, the 5th or 6th page, I think, or towards the back. Problem number 20, so it's definitely towards the back. So what kind of problem is this? What kind of problem is it?
Proportion.
It's a proportion. How do you know it's a proportion?
It says proportion.
So it's proportion, okay. So it's a proportion, which means it has to be either a hypothesis test or a confidence interval. Which one is it? Confidence interval. It says confidence interval.
Yeah.
Good. So we know what kind of problem it is. So then you should think about what kind of calculator function you should be using for that. So consider that as you're doing everything. Okay, so we said this was what kind of problem again?
Proportion.
Proportion and a
Confidence
confidence
interval.
interval. So, but it's a proportion. It should start with what? My calculator function should start with what?
One prop Z.
One prop. And if it's a confidence interval, it should end in what?
Interval.
Interval. Right, so you need to find something that starts with proportion, one proportion, and ends in interval or int. So that's one prop Z interval is what we're using. And I would say we probably want to do step C. If you want, you can do step C. If you want, you can do step C first. And that will help you find your A and B if you like. All right, so we did,
Just text me what's your availability. What day you can do
you all did
it. You want to do it Starbucks or?
stat test, one prop Z
No, no, no.
interval, and you put in the value. Calculate, bam, there you have it. 0.752 to 0.829. And also gave you your p hat, which is your best point estimate. .791. 906. Okay, great. Now I need to find my margin of error. Well, my error is just my p hat minus my lower limit. Yep. 0.791 minus 0.752, and you got 0.039. Okay, so now we're going to change it up a little bit. And instead, we're going to do this. Same problem, only instead of that many people, it's going to be 76.9% said it's going wrong out of 745. So now it's a similar problem, only we're doing a little bit different, a little bit of a twist on it. All right, so everybody work on this one. Give you folks 2 minutes, 3 minutes. So here, yep, I'll give you